All right, so we've got solving multi-step equations, which pretty much is like two-step equations. As we're getting into multi-step, really the multi-step is that we have to simplify before we get into our two-step process. So you'll see that here. So our essential question here is, how do you solve an equation that contains multiple operations? And it's the same question and the same answer as 2.2. You take it one step at a time. All right, and that's what we're going to focus on. Here we'll have that extra step in the beginning, which will be essentially doing the simplification. All right, so here's what we have, and we're actually going to use this for a few of our lessons. The SEED, or SEED, you want to simplify each side of the equation. So that's the new step that's kind of added. This one right here is actually kind of looking forward to what we're going to be doing, so it's good and bad depending on how you think about it, but I wanted to throw it in so we didn't have to learn, hey, now we're going to throw in another rule. So this one is here, but we won't need it today because this is already done for us, and that is to eliminate the variable from one side, meaning you want all the variable terms on one side of the equation. And then you're going to eliminate the constant term from the side with the variable. So what we end up with is a side with the variables and a side with the constants, but they're not intermingled anymore. Then we'll have a division problem right at the end to help us kind of solve that. So here was the first example, and remember the first step now is simplification. And there's two that you're really going to see here, and that's combining like terms, meaning we have it pretty simple. This side's done, but this side, I can combine the 5n and the 2m. Now notice they're both on the same side of the equation, so don't get confused with trying to eliminate it. We're not eliminating 2m, so we're not going to do minus. We're combining, we're cleaning up because they're both on the same side of the equals. You could almost ignore the equal sign and just look at this piece. So 5m and the 2m is the 7m. So that's done with our simplification. The first E is to eliminate the variable from one side, and you can see there's already one side without a variable. Now next week we'll see that we'll have to do that step because there'll be variables on both sides. The third step was to eliminate the constant that's on the side with the variable. So eliminate means I'm going to do the opposite. Remember, that's a lot different than here. Here I was simplifying, so I was cleaning up, I was combining them. Now I'm eliminating, so I do want to add 23 to get rid of the minus 23, and I do that to both sides. And the last step is to divide, and that would go, if we go all the way back to 2.1, our one-step equations, this is times 7, and we're going to divide both sides by 7, and that will give us our answer. So m equals 4. So then you had the U try. And once again, I kind of put this over here. Notice the eliminate the variable is going to be done every time on this lesson. But this looks a lot like our example, and that's the whole point, is we're going to do the same thing. We're going to combine the variables. Once again, we're combining them. We're cleaning it up. We're not eliminating. 11m minus 6m is 5m. Then it says eliminate the variable on one side. Well, that's already done. There's no variable over here. And then eliminate the constant on the side with the variable. So to get rid of a minus 8, I'm going to add 8, and I have to do that to both sides to balance it out. And then my last step is to divide, which you can see this is multiplication of 5, so we'll want to divide by 5 to take care of that. The next one, this is an example, and this is using the distributive property. All right, now I know some of us struggle with the distributive property, but we're literally going to multiply the negative 8 times the 2x and then the negative 8 times the negative 1. All right, so negative 8 times a positive 2x is negative 16x. Negative 8 times the negative 1 is a positive 8. Then we're going to subtract 8 from both sides. So when I subtract 8 here, I subtract it to get rid of it, to eliminate it. Here I subtract 8 to balance both sides out again. When I do that, I end up with negative 16x equals 28, and my last step would be to divide. So whatever, this is called the coefficient. The number in front of the variable is negative 16, so I divide both sides by negative 16. Now, if you got a decimal, negative 1.75, that's great. Okay, it didn't say it had to be a fraction, and since it's not rounded off, it's just as good as -7/4. So here was the U try. Once again, simplifying, and you can see this looks a lot like the one we just had an example for. So I'm going to distribute the 3. So 3 times 2x is 6x. 3 times -6 is -18. Eliminate the variable on one side, that's already done. So I'm going to eliminate the constant on the side with the variable. So -18, I'm going to add 18, and I have to do that to both sides. And now you can see it gives me this problem, which to undo multiplication of 6, I'm going to divide. And if you forgot that, it's in the seed. So we can kind of see it there as well. Now this got a little more challenging because we asked you to do some word problems. The more we practice, the more comfortable we'll get with word problems. So we can see here, this one, we're kind of looking for what we need and what we don't. Martha takes her niece and nephew to a concert. It's great, but that's not part of what we need. She buys t-shirts and bumper stickers, okay. Now here's something, the bumper stickers cost $1. Martha's niece wants 1 shirt and 4 bumper stickers, and her nephew wants 2 shirts but no bumper stickers. If Martha's total is 67, what is the total cost of 1 shirt? So if you click the slides, they'll have some crazy stuff for you, which is nice and good. But just to break it down a little, I know Martha's niece wants 1 shirt and 4 bumper stickers, and her nephew wants 2 shirts and no bumper stickers. So if we let S equals shirt, and I'll do B equals bumper sticker. Wow, that's whatever. Bumper sticker. All right. So we have 1 shirt plus 4 bumper stickers, and then the nephew wants 2 shirts and 0 bumper stickers, so we don't need to write that. And I know that equals 67. So that's just a basic equation. And you can see if we cleaned up here a little, I'd have 3 shirts and 4 bumper stickers. And we know the bumper stickers were each $1. This is an S. So now we could solve this problem. Subtract 4 and then divide by 3, which should be 21. So we know that each shirt costs $21. So moral of the story is here, try writing it out first. Don't panic. All right. Now, if you were to go ahead and click all this out, you could see that it breaks it down a little cleaner and a little tighter and all the steps. So you can go back and look at that if you'd rather, or you can replay the video if you want to see kind of what I did. So here's another one where we could click it out. You couldn't on your notes, but you can on these. And I'm looking, they're buying guitar strings. Noah buys 2 packs of strings, so that's 2S. I'm going to use an X because you saw my S's look like 5s. So I'm going to do X equals strings. Kate buys 2 packs of strings and a music book. All right, so we'll use B for book. The book costs 16 and the total cost is 72. So all of those items added up is 72. 2x plus 2x is 4x. The book they told us was 16. So now I have an equation to solve. So remember, just do your best. I mean, these take some practice, so as we get better at them, we will feel more comfortable with them. They'll feel easier, if you will. So 72 minus 16, let's see, 2, 4, 66, 56. And then if I divide both sides by 4, I would get 14. Let's see, 40 and 16. All right, so if I didn't screw anything up there, this would be $14 for 1 pack of strings. Remember, I let X equal the strings, and that's what I sold for. All right, so I hope that all helps. I'll end by clicking this out, and we'll see if I was right. Hey, look at that. So anyway, once again, don't avoid the word problems. Give them your best shot, and we will improve at them. I hope that helps.